In this video, we will be solving for molality using the boiling point formula. The problem is, what is the molality of a solution containing 40 grams of AlCl3 and 650 milliliters of water if the new boiling point is 102.1 degrees Celsius? We will have to use the boiling point formula, which is delta T sub B equals K sub B times M times I. Now, T sub B represents the change in boiling point. We weren't given this directly, but we can easily solve for this using the formula new boiling point minus original boiling point equals the change in the boiling point. In this problem, that would be 102.1 given in the problem minus 100, which is the boiling point of water, which is 2.1. The next variable is K sub B. That represents the Molal boiling point constant, and the Molal boiling point constant of water is 0.51 degrees Celsius over M, which is what we use. The next variable is M, which stands for molality, and that's what we will be solving for. Finally, I stands for the Van Hoff factor. The Van Hoff factor we find using the ions in the compound. In this case, that would be Al and Cl3. So we have to look at the charges of each of the elements, which in this case would be aluminum, which is positive 3, and Cl, which is negative 1. We can ignore the negative and we can add the two together, 3 plus 1, which equals 4. So now that we have all our numbers, we can plug in the numbers and solve. So we put 2.1 in for deltas of T, 0.51 for the boiling point constant, and 4 in for the Van Hoff factor. Now to get M alone, we have to divide by both sides of 0.51 and 4. So on this side, we divide by 0.51 and 0.4, making sure to use the proper notations on the side, degrees Celsius over M, and 0.51 times 4 on this side. And if you put that in your calculator, you should get M equals 1.0294 continuing. Now we have to use the proper significant figures, so we look back at our original problem. This number has 3 significant figures, this one has 2, and this one has 4. So we use the smallest number, which is 650, and that's 2 significant figures, so our final answer is 1.0 molality.